Welcome back, Advanced Algebra 2 Wildcats. All right, if you would, please pause the video and update your table of contents. All right, now that your table of contents is updated, I want you to take a look right here where it says, it originally said inverse functions, but I've realized that we have a part 1 and part 2. So we're going to make this inverse functions part 1 and make this inverse functions part 2. So first off, go to page 8. And at the top of inverse functions, where your examples are, put part 1. Okay, now let's go back to our table of contents. All right, so our examples are going to be inverse functions part 2 on 9. Okay, so let's put this aside. All right, so on our inverse function assignment at the top, go ahead and put part 2. Now, before I forget, make this 9 and tear off the example page. This will go in your journal. This will be turned in for a grade. All right, so I'm going to leave example number 1 for class discussion. There's a lot going on with it. So we're going to talk in detail about example number 1 in class. Okay. Now, I still want you to try example 1 before you get to class, but just know that there's going to be a lot we're going to add to it and discuss it. All right, so let's look at example number 2. Now, before we go into example 2, we need to go back to our journal and review something. So in your journal, turn to the families of function foldable on 5. So we're going to go to that. And then you're going to turn to the tab that says inverse, so the one in the very, very back. Okay? So let's review how to find an inverse. Okay? The graphical will reflect over the y equals x line. That's important. We're going to do that on each of the graphs today. Okay? Also, to test for an inverse, we're going to do a horizontal line test. We're going to do that as well. Okay? All right. Algebraically, we switch x and y. That's step 1, switch x and y. Okay? Now, you could use composition of functions. We're not going to do that, okay? I'm just reviewing that there. We're going to do step 1, switch x and y. Okay? And the other key here is to find the inverse, we flip the domain and range, okay? All right, so with those reviewed, let's come back to our example. All right, so example number 2. Okay, so first we're going to graph y equals x cubed. Okay, so to do that, we go to on, new document, no, add graph, and then x cubed. So x, and then we're going to press this key right here to get the cubed. Press enter. And then we're going to press Control T. So I press Control and I press T to get the table. And then so on our paper, we start at -2, so I'm going to move up to get to -2. Now, if you don't have an inspired home, you might have an 84 or Desmos. Either one of those will give you the graph and table. Okay? But if not, in the video, we have this together. So let's go and complete the table. So we have -2, +8. We have -1, -1. We have 0, 0, 1, 1, and 2, 8. Now let's go back to the instructions real quick. It says make a table for each function, which we did. Name the function, state the domain and range. So let's name the function and state the domain and range. All right. So to name the function, let's go ahead and put the name right here. Okay. All right. So I'm hoping that you see the 3 or the x raised to the third power, and you know that that's a cubic function. Okay. All right. Now the domain and range. Let's go and look at the graph. So from left to right, the domain is all real numbers. Okay. And then from bottom to top, the range is all real numbers. All right. So now let's go back and look at the instructions. It says, for the second column, it says find the inverse of each function by making a table. Keyword making a table. Then state the domain and range of the inverse. So to find the inverse, making a table, you switch. All right here. Switch x and y. So here, when we switch x and y, so the x is on the left, they're now on the right. So really, when I say switch x and y, I mean switch the x and y values. So the x's are now the y values, and the y values will become the x. So then the y values are now the x, so that's 8, -1, 0, 1, 8. Please don't overcomplicate this. Basically, this switched here. Okay? Now, before we move on, let's not forget, we're going to name this. So I'm hoping that you see it's the cube root of x, so you know it's the cube root function. All right. Now, to get domain and range, let's go ahead and graph the cube root of x. So I'm going to new document, no, add graph. Now to get the cube root, we're going to press Control and up key. I'm going to put it 3, and then X, press enter, and then you're going to press Control T, and let's just see, let's just verify that in fact we did the inverse. -8, -2 matches, -1, -1 matches, 0, 0 matches, 1, 1 matches, and 8, 2 matches. Okay, so let's look at the domain range. All right, so from the main, from left to right, it's all real numbers. And then from range, from bottom to top, it's all real numbers as well. All right, now let's look at the instructions for the third column. It says graph the function, keyword here, function, inverse, and graph y equals x. Now let's go ahead and graph y equals x in yellow. Okay, so we're going to graph y equals x in yellow. And while I'm thinking about it, let's graph the function in blue and the inverse in red. Now, you don't have to use blue and red and yellow. You can use whatever colors you have available. Just know that you might specify it here. So when you look at the examples, you can line up there. Okay? So let's first graph the cubic function, and that is in blue. So the cubic function is negative 2, 8. So negative 2, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 1. Zero, zero, 1, 1, and 2, 8. Now, I had a student actually on September 6th during 6th period say, I learn better when the teacher makes mistakes and I can catch them there. Okay, I've made a mistake. This point is incorrect. So I'm going to put an X. Okay, if you ever make a mistake on a point, put an X. And in fact, this is actually negative 2, negative 8. Okay, so it's an easy fix. But now since I made a mistake here, I also need to correct it here. So this is actually becomes negative 8. Okay, so here, this is the point should be negative 1, negative 2, 1, 2, 3, 4, 5, 6, 7, 8. So negative 8. Okay. So now we're going to connect the points. All right. Now, we're going to graph the inverse in red. So the first point is negative 8, negative 2. So this is negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and 8, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. All right, give you a few seconds to pause that and update your graph. All right, now to test for an inverse, we do a horizontal line test. Now, notice, if I look at the horizontal function, I go across, okay, and let me do that. Let me do the horizontal line test in green. Now, if you draw a horizontal line across the function, and the horizontal line only crosses once, you know that the inverse will be a function. So we know that this is a function, and we know that the inverse is a function, basically by drawing a horizontal line test of the function, okay? That's going to be important when we get to example number 1, and that's part of the reason why I'm going to do example number 1 in class, because when we do a horizontal line test of example number 1, it gets kind of complicated because something happens, and so keep that in mind. All right. Now the next thing from our notes is that we know that if they're inverses of each other, they'll reflect over the y equals x line. So let's do that. Let's graph y equals x. So we know that y equals x is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. Okay. I'm not going to do it in the video, but if you want to check the points, you can go y equals x. Now remember, in the calculator, it's going to be f of x equals x. But same thing, okay? But this is y equals x. And so you'll see that they reflect over each other across the y equals x line. So these are inverses of each other, and they're both functions. The y equals x cubed is a function, and the cube root of x is a function. And I also want you to see from the video is that y equals x cubed and y equals cube root of x are inverses of each other. Now, in essence, I could go on and do example 3, but I think I want to stop here and let you do example 3 on your own, because I think these you should be able to do based on example 2. Example 3 is not as difficult. So try example number 3, and then go back and then try example number 1. But understand that there's a lot going in example number 1, and we're gonna need to talk a lot about this in class. Okay. All right. And also remember, in class, ask me questions. If you still have questions after class, or you want to ask questions before class, I'm in tutorials in the morning, tutorials and during lunch. So there's lots of time to ask questions. Okay. All right. So remember to ask questions. Try example number 3 and example number 1. In that order, example 3 first, then example number 1, and have a terrific Wildcat day.